used in hydrologic forecasting in the Bureau of Meteorology of Australia. Actually, I figured I'd start out with a little bit of an experiment. Basically, I'm going to put a trivia question up on the screen, and so if everybody could, kind of like close their computer and maybe get a pen so you could write down your answer. What we're going to do, basically, the idea is to get us thinking about probabilistic forecasts and calibration of forecasts and quantifying uncertainty. Remember, there's no talking. You're going to have about 30 seconds to put down your answer, and you can't really talk with anyone else because this is a competition. If you help someone else, then you're basically hurting yourself. So what I want you to do is write down two numbers, and answering the question, basically I'm 80% confident that the population of Taiwan in September 2014, because that's basically what's on Wikipedia, is between a lower bound and an upper bound of people. So, I look on this table, I see there's somewhere between 3 and 7 pens, right? I'm 80% sure of that. There's probably 6 or something. So what we're going to do is figure out who actually gets a range, like the observation is within your bound, but who has the narrowest range is going to win a prize that's in my pocket, right? So does everybody kind of understand, what you're supposed to do? Basically, 80% chance the real observation's in your range, 10% chance at the low end, 10% chance at the high end. All right, so I'll start the clock at 30 seconds, and maybe Liz at the top, if you could check and make sure nobody's looking at their phone for any kind of answer or anything like that, and just shout if you see it. So, all right, 30 seconds, go. Now remember, if you're uncertain, put a wide range. If you really know it, put a narrow range. All right, we are at 15 seconds. Only have a little bit of time left. 5, 4, 3, 2, 1. All right, pens down. And does anybody really feel like they got it? Like they're really confident that they've got the right answer? Anybody? No? All right, so the answer is 23,410,280. So if your range is kind of like bracketing this observation, put up your hand. No, so if it's your lower and upper, so there's 1, 2, 3, 4, 5, 6, 7 people. And so who had the smallest range? What was your range?
20 to 100.
Right, okay. Did anyone get smaller than that? 2 to 35. That's pretty good. 5? 5? That actually doesn't have the observation in it. Right, so you have a very narrow range, but unfortunately you missed it. So 2 to 25, anybody else? What was it?
20.
Wow, right, okay. I don't think anybody can. 15 to 30. I think the 20 to 30, is that a tie? Or, I don't know. Oh yeah, okay, all right. So you get a chocolate bar, all right? Enjoy it. There we go. Great. So if anybody noticed, 7 people out of 33, so that was only 21% of the people in the room had the right range. So, like Jan, what does that mean for kind of
unreliable, uncalibrated work?
But I mean, we're professionals that work in this field. Yeah. So I've actually given this kind of survey in 5 different countries, and this is absolutely typical that about 25% of people get the right range. And so people are naturally overconfident. And so when you get a deterministic forecast from the Bureau of it's going to flood, and people complain about, well, you should really be quantifying your uncertainty. Well, there's very interesting questions about if people really understand that uncertainty in a well-calibrated way. And so what does this mean for making probabilistic forecasts? So I guess to start the talk itself, to give you a little bit of background about myself, within the Bureau of Meteorology, we are responsible for water forecasts across the country, and I'm the head of the modeling group for flood forecasting within the head office in Melbourne, Australia. In case you can tell from my accent, I'm originally American, moved to Australia about maybe 6 years ago or so. And I've been involved with HEPEX since, I think, around 2008 or so. And I'm one of the volunteer columnists. These are a couple of the different posts. Trying to make it accessible, maybe a little bit of scientific content, what is a good forecast, occasional controversy, like is a lack of competition affecting innovation and operational forecast. There's a little bit of science here. This is a recent plot that shows the skill of operational as-issued water supply forecasts in the western U.S. through time for different lead times. So this is April, for like an April through July forecast, and these are longer lead times. At the top is better, at the bottom is worse, and a 20-year moving window showing that basically forecasts got better and then they got worse over time, which is actually a pretty shocking result when you think of there's satellites and scores of PhDs and computers, are all kind of new things, but the actual skill of the forecasts haven't changed much. Indeed, if you look at March forecasts, they're worse than have ever been issued. And part of this could be related to climate change. The jury's still out, but right. So to take some inspiration from Albert, I put the summary first. Seems to be a new thing. Maybe this is how it'll go from now on. But basically, Australia provides a whole range of forecasting services from seasonal right down to floods. And the shape and character of those systems are really different based on how long they've been around, and then also kind of the different methods to produce them. But you generally find that the seasonal forecasts are very highly formalized and objective, and the flood forecasts are a bit more kind of basic models, lots of humans in the mix trying to adjust the forecast. And there's interesting issues when it comes to using weather forecasts and flood forecasting in particular. Now, some demographics or networks within Australia itself. So each one of these dots here is a rain gauge that we use for our flood warning system. This is different river gauges, and you can see here an outline of France where there's absolutely no measurements whatsoever. So Australia has a population, I would say, about the same as Romania, and the kind of GDP of Spain, but the area of Australia is bigger than the entire EU. So you can imagine there's very low densities of people, which makes it a little bit hard to issue an operational forecast service. A lot of people are around the coast, not so many in the interior. And you see a definite seasonality of, say, this is the percent of flood warnings issued by month for different states, starting with the north and going to the south. So January through March is the wet season in the north, and then June through October is kind of the wet season in the south. For different forecasts that we produce, at the shortest time scales, flash flooding is not something that we officially are responsible for. It's not really a hydrology function as much as it is a meteorological, rainfall-based severe weather product. Someone will look at the radar if a big cell is developing and it's bearing down on a certain area. They'll produce, sort of like scrollers along the bottom of the TV and, the different warnings. The flood warnings themselves and watches have actually been issued since about 1955, and still the primary product is just text bulletins with forecasters in each state issuing products basically as needed. You might go several months without issuing a flood warning, and the models themselves are very simple, just event-based models. And here's a typical product. Heavy rainfall is falling in a particular catchment, flooding is basically imminent in a certain area, and they'll write right into the product. At this stage it's not possible to predict the flood peak because of uncertainty of how much more rainfall will fall. Strangely enough, right below it there's actually a prediction of a flood peak, but I think it's just for a particular gauge and maybe not so much downstream. So if you were to compare this, there's also a short-term forecasting service, which is relatively new. It began in 2013. Right now it's in kind of registered user, and then it will be a public release in 2015. And this is the areas that are covered so far. And if you go and click in, there's basically hydrograph-based products, not really text bulletins, but hourly resolution, deterministic predictions out to about 7 days. And this is all completely centralized, automated. It's run on a scheduler. using a continuous rainfall runoff model, GR4J, with a little bit of error correction as well. And then finally, there's seasonal forecasts, which have been around since 2010. And these two are centralized, automated. The forecast is the model output, and they're very highly probabilistic. They're made using statistical methods, but they'll be dynamical techniques pretty soon. And the visualization of this stuff is really quite more sophisticated than the flood forecasts. And part of that is because the system is new, and there's not really a legacy to contend with of existing products and methods. So for the seasonal forecasting approach, what I'll do is I'll start at the, I introduce the different products going from short timescales up to long. Now what I'll do is say about how they use weather forecasts going from long timescales back down to flood timescales. So the techniques they use are basically relating rainfall and streamflow data, antecedent runoff, whatnot, with different, say, climate indices, and it's a very sophisticated statistical model, the Bayesian regression technique called the BJP, Bayesian joint probability. And a new product that's actually in the works right now is using global climate model seasonal forecasts with some kind of downscaling and analog matching and whatnot to produce streamflow forecasts as well. And then at some point next year, these two will be statistically merged into an optimal product, and then that will be the product that goes out to the web. And these are monthly forecasts, 3 monthly forecasts, so it's basically zero lead time of what's coming in. Now, how the rainfall forecasts are used, there's basically large-scale climate models, 240-kilometer resolution, which will shortly improve to about half of that. There's really pretty sophisticated downscaling techniques to find realistic weather patterns and generate additional ensembles until finally you get about 155 ensembles at a very fine spatial scale that can then go into the hydrology model and create a whole large ensemble of different forecast products from that. So it's very hands-off. There's no forecaster here at all. It's all on a scheduler. The products that they produce are richly visual. There's pie charts here of probability of wet, near normal, and dry. There's a chart here that tracks the progress through the season of the flow. So you've got accumulated flow climatology, and then say every 3 months or so what the actual observed was, and then what the kind of range of the forecast was. So you can see how the forecasts are tracking, but also how the flows are coming in. There's exceedance probabilities, there's PDFs, box plots, the whole works. Basically anything that you could ever want. And for the rainfall forecasts that are used, POAMA 2 is a 250-kilometer model as mentioned. They have these retrospective forecasts that they've issued for about 30 years or so, and have a reanalysis. There's ensembles for both the forecast and reanalysis, and it's daily resolution out to about 9 months ahead. And you can see the spatial resolution here. The maps themselves are the correlation of precip between the model and observed out at 1 week, and that's pretty good, maybe not so good at week 2. Right. Now, you can contrast that with the short-term forecast, the sort of 0 to 7 day streamflow forecast, and the flood forecasts are increasingly using what are called the access models. The dynamical part of it is basically a reproduction of the Met Office model. There are no retrospective access forecasts like there are with the climate forecast, so we can't really do a lot of experiments with kind of calibration based on retrospective forecasts. But besides, in the short-term forecast, the NWP is used deterministically, and ensembles will be generated relatively soon. There's lots of different spatial domains, 40 kilometers covering the entire globe, regional forecasts to 12 kilometers, and then these nested domains over each one of the capital cities where lots of people live. And this probably covers 95% of the population. Now, when you compare the scale of those forecasts, this is Melbourne here, and Canberra's up here. Sydney would probably be somewhere up here. The red outline here is a typical flood warning catchment for the Bureau. Say this is the Ovens catchment, it might have 17 different stream gauges within it, maybe like 100 sub-models of the hydrologic areas. Now, this does have the longest lead time of the forecasts, and this is currently what's used to feed the deterministic short-term flow forecast. Naturally, you could say there's an issue there, that the observations obviously have a finer spatial scale than the forecast, and there's all kinds of biases that you should adjust for. But currently the product doesn't adjust to those biases. It basically goes straight into the models. Now, the finer resolution forecasts, they have shorter lead times, but you're starting to approach physically realistic rainfall patterns until finally you get down to about a day and a half lead times and 4 kilometers. This is actually comparable to what the hydrologists want to use. Much finer resolution, it's almost overkill because you're finer than your rainfall network. The scale of the forecasts for rainfall versus time, this is over a 4,000 square kilometer catchment, the Ovens River I mentioned. Basically with lead time, the scale is really quite good at short time scales, but worse at longer lead times. And then for daily rainfall, again, it's really quite good, but for hourly, it's not so good. So our impression is that NWP gives you a general impression of something might happen somewhere at some time in the future, but you can't really say exactly where or how much or when. Now, for the flood forecast, there's actually a long history of using weather predictions in the flood forecast. Pretty much every day, the weather forecasters have a briefing. Oftentimes, there's a special briefing for the flood forecasters, much like if you wanted to go at 10:30 to the briefing here. And there's these hand-drawn maps from the meteorologists. Well, they'll say, you know, this area here, there'll probably be 40 to 70 millimeters, and locally 100 millimeters. And these are still produced. This is 2013. You know? And this is the official policy of the weather forecasters, and this is really what the flood forecasters should use. Now, the hydrologist then, this was our legacy forecasting software, which began in 2001 and is now being replaced. But really the only option that the hydrologist had was to put a sort of box of water over the catchment. A very simple scenario. You know, it's going to be 50 millimeters everywhere for 10 hours. And this is what the response to the hydrograph is going to be. You know, if you see a result like this, you'd say, well, there's probably pretty little chance that we're actually going to get up to minor flood level, so we don't really need to issue a product. But, you know, if it completely blew out over the top, then yeah, sure, you'd probably issue a flood warning. And of course, it's the gray areas in between that are a little bit fuzzy. Now, actually, with our new forecasting software, there's a lot more chances to get the model output from the weather models directly into the hydrology models. We didn't really use the NWP directly because of a kind of plumbing issue. You can't really process the files and get them to the models in a convenient way. And so now with the Deltaris Fuse system, which is called HIFS in Australia, you can basically look at a whole wealth of different rainfall possibilities and get you know, a spaghetti of hydrographs out the other end. Now, this is just combining deterministic forecasts from individual models. If you had ensembles on top of that, you know, you could really get a lot of possible things to look at. Now, policy-wise, there's a bit of an issue here in that when you're putting the NWP models directly into the hydrology models, it's a bit like, I don't know, what would you say? If you were taking medicine in pill form, you know, there's really only so much damage that you could do, but if you were injecting it, you know, like directly, then if you don't have proper supervision, you could really kill yourself. You know, this is actually pretty dangerous stuff. And, you know, this is kind of like taking our medicine in pill form, but this is actually, you know, you could really do damage if you use the wrong model output or if you've got some extreme or some systematic bias that you don't know about. And so there's been a lot of kind of worrying about our technology is outpacing our policy. It's very frequently we discuss about a couple years ago, there was a major flood in Australia, and there's a commission of inquiry and all kinds of legal investigations about what went wrong, why did the city get flooded. So we often discuss, if another commission of inquiry happens, are we going to be ready to provide the documentation and justification for what we did? And if you're just kind of rummaging in the bag and picking out a rainfall forecast, then well, that's not very justifiable. Now, you remember those hand-drawn maps of the weather forecast. Now, the meteorological guidance is in this GFE, graphical forecast editor style product that is produced every day. You get grids of the whole area. There are some edge effects, but it's basically meteorologists in each state create these grids of 3-hour mean rainfall and median rain, 25% exceedances. And there is a 10% exceedance grid internally, but it's not currently on the web. And the process of making these, there's many different rainfall forecasts that go into this, and then the meteorologist can shift things around as they believe is fit. And then it goes to a database of kind of distributions and historical observations, and it'll create a whole mess of grids which are statistically internally consistent across a bunch of different time scales and spatial scales and different exceedance probabilities. And we would hope that these are the best source of information because these are the official policy forecasts. If people ask, why didn't you use this? We would need a good answer. But you can't directly put this sort of thing into the model. You've got a field of, say, median rainfall over a certain area. Again, this is the Ovens River catchment. On the left is what that graphical forecast editor product is. On the right is what's directly out of the weather model output. These are typically smoother fields than these, and these are smoother fields than reality still. Now, one particular statistical issue is that they ask flood forecasters often, you've got your deterministic product, but what do you think is the worst case scenario? Well, people will put that 10% grid into the model itself, which statistically is not right. It's kind of like the peak of the median is not the median of the peak, that getting that 10% exceedance over that whole area really only has about a 2% chance, because there's spatial uncertainty of maybe the rainfall's here, and intensity issues as well. There are some advanced weather forecast products that are coming down the pike. Actually, as we speak right now, there's an intensive campaign of high resolution, basically a couple months of running over a limited domain over New South Wales, a campaign of 1.5 kilometer weather models, updated hourly instead of twice a day, out to short lead times. And Alan Seed, you might have heard of the STEPS framework, which they also use in the UK, are blending this information with radar fields and making ensembles, a very high resolution 6-minute forecasts. And hydrology is one of the projects here, and we're using this as an evaluation for how should we use these products, and should we do something different. So I'll finish off there that basically saying that some of the limitations of using weather forecasts operationally have been related to plumbing, in terms of not being able to get the files to the model, but that's pretty much changing, but maybe an issue for other places. We calibrate our models with a certain data set and forecasting with a different data set. This is something that the seasonal forecasts have paid a lot of attention to, but maybe less so on the flood forecasting side. We have issues of should you use the NWP or these official forecasts, and sometimes personally I like to see more information, but there's a sense on the flood desk of if you've give people a mountain of spaghetti, ensembles of ensembles from different centers and different models, you'll end up with an answer like, it's somewhere between 0 and infinity, which is not very informative for a flood forecaster. You need to ultimately decide how to pull the trigger, and so it's new information for people, but that's changing. Yeah, that's pretty much it. Thanks for your time.
Thank you very much, Tom. Question?
As you are advancing for this use of new forecast models with global information, are you also doing some training with people, or how are you handling this learning process?
Sure, yeah. So the question is about, as we bring on new products, what kind of training procedures do we have? And actually, that one of the major things that's changed in the Bureau in the last couple of years is a major effort on training. I'm the head of the forecasting or the modeling group. There's also a training group, which has a whole competency framework where people will take modules, sort of submit evidence of doing different tasks, and that's all new. And stuff like how you use short-term forecasts, concepts of ensemble forecasts are all content that's literally being developed a couple months ago and being delivered now. So it's something that we're very active on. And there's always a tension between how much you train people on kind of the concepts versus the sort of practical bench knowledge, but we try and do a little bit of both. Sure.
Can you say more about the Bureau's plan on restarting their medium range ensemble? In terms of weather, so.
Right. So when you say restarting, well, so the question is the Bureau's plans for restarting ensemble forecasts? Oh, right.
Whether they are planning to, I mean, I heard they're
sure.
planning to restart it.
Right.
Usually we do by a modern framework.
Right.
Do you know anything more about this?
Right. The question is, the Bureau had an ensemble forecast about 2010 that was switched off, and are there plans to switch it on? Recently, the Bureau procured a new supercomputer, and there's a sense that, you know, one of the justifications for that is generating ensemble forecasts. My impression is that within a year, the ensemble forecasts will again be produced operationally. I'm not sure if that's the exact date, but it's not 10 years and it's not like a month. And within the Bureau, there's also a group called CAWCR, which is the Center for Australian Weather Research, and that's the research arm of the Bureau, and they have been running operational, or sort of pseudo-operational ensembles for quite some time internally, but the different part is the real-time operational products going out. Yeah. So soon, watch the space, as they say.
You showed a nested domain to the weather forecast. I noticed the outer domain is close. What is the, you know, like the bunch of the inner domain, like the window?
Yeah. So.
I didn't know that.
Right, the question was about the spatial resolution of the different nested models. So that the outer grid is 40 kilometers, inner grid 12 kilometers, and then 4 kilometer grids for the city grids. And then this area here is where we're doing the experiment now with 1.5 kilometer gridded forecast for a couple months. All right, I think we're at the top of the hour. And are there any questions online or anything? Or
No.
okay.
Okay, thank you very much.
Great, sure.
And I think the first morning question now, just a few things. You know, there's some people that are leaving already now, so the talks will be online as well afterwards. We'll post it to what we register.